ladies and gentlemen. Yesterday we looked at the trig functions when it comes to sum of difference properties. So I asked you to do 13, work on problems 13 through 20 for homework. Kind of looking at it, doing sine, cosine, and tangent to all of these. And they first give you 11 power over 12, and they show you what it splits to, right? So that's the given information. So in your future reference, after this class, for you to understand, you can split up radians, okay? 11 power over 12 is 3/4 plus power over 6, right? So just be aware of that. They're going back to 45, 45, 90, 30, 60, 90 triangles, right? The radian measures of such for those. So let's look at doing number 13 with a sine. So compare my work to your work. Notice that I put the in black here. I rewrote it sine 3 power over 4 plus power over 6. Identified who U and V was. And when I identified who U and V was, that allowed me to set and take and substitute those values straight into the property, right? And then I found their values using my unit circle. And I multiplied them together and add them, and I got square root of 6 over 4 minus square root of 2 over 4. And when you rewrite with one common denominator, square root of 6 minus square root of 2, all over 4, right? Any questions? Anybody? Anybody not get that answer? Everybody got that answer? Y'all solid on the signs? What's wrong? All right. So let's look at cosine. Y'all ready? The cosine, even on the properties, is a little bit different, right? The sines go sine, cosine, plus or minus cosine, sine, right? But the cosines, when you split it, they're all cosine, cosine, sine, sine, right? So please be aware of that. Again, I rewrote it so that I could identify who my U of V was, and I substituted into the property. And then in blue, I found the appropriate values on the unit circle. So the cosine 3 power over 4 happens to be negative square root of 2 over 2. Make sure, and I didn't do this yesterday because we were dealing with everything in the first quadrant. But you could be in any of these quadrants, right? First, second, third, or fourth, right? In your ordered pairs, your x's and your y's, your cosine and sine, could have a negative value applied to it, right? So make sure that you're aware of that. So that's why it's negative square root of 2 over 2 times cosine power 6 is square root of 3 over 2. That gives you negative square roots of 6 over 4 minus the value of sine 3 power 4 square root of 2 over 2, and the sine of power 6 is nothing more than 1/2. You multiply them together, you get square root of 2 over 4, and of course, you combine your answers there in red. Any questions on that? Anybody? Y'all good? Now, let's discuss this. You ready? So, I didn't do anything different on this one other than, well, I didn't. I plugged in our 3 power 4 plus power 6 into the tan, right? Identified the U to V, right? So looking at that unit circle, you have cosine and sine, right? So how are we going to get a tangent? Anybody? Huh? Y over x. Why y over x? Because y represents who? With the sine. There you go. So yeah, she's going right back to her trig identity, right? Tangent is sine over cosine, right? So it's just y over x, correct? So I basically need to do this. I need to find out what the value of tan 3 power 4 is and the tangent of power 6. Now what you're going to do is you're going to put your y value divided by your x value, right? Sine over cosine. So what I need for you to do is take about 30 seconds and evaluate those for me, please. Can you do that?
I'm not sure.
Yeah. Y over x. You got ordered pairs, right? The y's are the sines, the x's are the cosine, right? So you put those values over one another. Go ahead. Give you about, I don't know, 45 seconds or more, about a minute. Go. Well, here's the values that I got. Okay. So the sine of 3 power 4 is square root 2 over 2, and the cosine is negative square root 2 over 2. And when you look at that, well, square root 2 over 2 is nothing more than the same, right? So this whole configuration should have been who? Negative 1. And when you do the bottom, and you can do it on your calculator, right? You get square root of 3 over 3, correct? Questions? Now, what would you say if I told you that these values for tangent, the power 3 power 4 and power 6, they're going to be true, constant, all the way around that unit circle. Meaning, if I were to look at any radians that had a denominator of 6, then their answer for tangent would be square root of 3 over 3. The only thing you'd have to do is make sure whether it was positive or negative. Does that make sense? So what I need for you to do, and I'll kind of show you this, is there's power 6 right here. So that would be square root of 3 over 3. It's just positive, right? If you go to 5 power 6 on your unit circle, the tangent value of it would be square root of 3 over 3, but making it a negative square root of 3 over 3. Does that make sense? Because one of your coordinates is positive and one's negative. Yes? So what I'd like for you to do is this. See how you got your ordered pairs? Up here on the regular board, square root of 3 over 2, comma, 1/2 as an ordered pair. If you write the tangent out beside that, then you'll have it. You never have to compute it again, right? How fast did it take? So, at 5 power 6, you can write negative square root of 3 over 3. At 7 pi over 6, you could put positive 3 over 3, positive square root of 3 over 3, right? At 11 pi over 6, you could put negative square root of 3 over 3, correct? Y'all see that? Yes? Anybody confused about what I just did? Okay. So, here we go. Got a big old unit circle, right? Look at that circle. That's pretty good. Hey.
Look at the yellow. No, the orange. Look at it. There you go.
I tell you what, these people are so much of a critic. Huh?
I just have OCD.
OCD? You have OCD?
Yes.
Yeah, I have ABC.
Well, no, I'm not gonna say.
No, don't. Please be nice. Okay, So this is what I'm talking about when I say 11 pi over 6, pi over 6, 5 pi over 6, 7 pi over who? 6. Does that make sense? Do you see how all my tangents are square root of 3 over 3 for those with a denominator of 6? Yes? But they're positive and they are negative. How do I know if they're positive or negative? Look at your ordered pairs and your signs, right? Yeah. Now, the cool thing, you can do that with pi over 4, right? Correct? Oh. Yeah. Keep writing that out there. And there. 7 pi over 4. Okay. Now, y'all told me that a 45 degree, a pi over 4 was what? 1. This one would be negative 1. That one would be what? And that one would be what? Do you see what I'm talking about? Yes or no?
Yes.
Okay. Now, what's the only one that we have not calculated yet? Over 3. It's denominator of 3, right? So, ladies and gentlemen, pi over 3. What would pi over 3's tangent be? Huh? The who?
Am I right?
I don't know. Are you right? The what now? It's what now? Just square root of 3. Yeah, not the, okay. Yeah, you were setting up the fraction. But if you evaluate and simplify those fractions, you would get, guess what? Square root of who? Are y'all agreement with me? Now, so on your unit circle, which you're going to be able to use, you have sine, cosine, and tangent already calculated for you, don't you? If you write this down, right? Correct? Yeah, that's why I had this right here. Like, please write it beside your ordered pairs so you know which one it is. Like that. You don't want me to talk like boys done. Jenny. I know. All right, y'all finish this. Finish your unit circle, okay? So we went back and we drew our unit circle. We put in our tangents for each one. Y'all see the color patterns? That's pretty cool. Think about that. Good, right? Why is it that tangents are all positive in the third quadrant? Anybody? 2 negatives become a what? That's right, because it's sine of cosine. A negative divided by a negative is a positive, right? Yeah, good. Here we go. Oh, no, I don't want that one. Sorry. I want this one. Now, okay. So here's what I have performed. So I took the tangent and I said, okay, it's a tangent u plus b, right? So I wrote the tangent of 3 pi over 4 plus tangent of pi over 6, all divided by 1 minus the tangent of 3 pi over 4 times the tangent of pi over 6. Ladies and gentlemen, we have those values, right? So all you have to do is substitute those values into it, correct? And evaluate. So that's what I need you to do right now. Okay? You can't handle the answer. All right. Y'all evaluate. I'm going to give you a minute to evaluate, please. Get it in simplest form. Okay. Alright. Now. Yeah, okay. Here, check your work. Did you get square root of 3 minus 2? Hold up. Oh, you got that. Alright. You what? You're not looking at you, nerd now, girl. Alright, now. I want to ask you something. When we did sine and cosine, did you find patterns?
Yes.
The denominators were always what? No. When you multiply, they become 4. That's correct. But it was like square root of 6 and square root of 2, correct? Yes? All right. Do you think there's going to be a pattern when it comes to maybe tangents? Depending upon what combination that you use, right? Could be. So here's what I want you to do. All right. If there's no questions on this one, I need you to look at number 15. Now you go, well, Palmer, which one is number 15? So before I move this to number 15, so you can copy down and find the tangent of it, I want you to find the tangent. I think you're good on sine and cosine. Well, make sure you're good on tangent. Is there any questions on this one? Okay, here we go. Number 15. 15. Ladies and gentlemen, we're going to give you 2 minutes to do number 15. Only the tangent, please. Okay, so let's look at this. You get to 9 pi over 4 and you're like, I can't find the tangent value of it, right? Agree? Well, ladies and gentlemen, watch me. Okay? Ready? I'm going to do this. Divided by 4 is the 4 denominators in blue, correct? Okay, so here's 1 pi over 4. Here's 2 pi's over 4. 3 pi's over 4. 4 pi's over 4. 5 pi over 4. 6 pi over 4. 7 pi over 4. Back at 2 pi is 8 pi over 4. So 9 pi over 4 is really who? Pi over what? Y'all remember that reference angle? Not reference angle, coterminal. Angle measure between 0 and 360 or 0 and 2 pi, right? 9 pi over 4 happens to be a full revolution and a quarter. A pi over 4, right? So if you, on your calculator, if you were to do 9 divided by 4, you'd get 2.25, right? Yes? The 2 would mean a full revolution, right? So minus 2, and you're left with 0.25. Hit the little button above the enter, and you turn it back into a fraction. Guess what fraction? 1 over 4, which is pi over 4, right? Yes? So that is an option. They can give you a radian measure that is greater than 2 pi. So you'd have to find the coterminal angle, right? How about that? Some crazy stuff right there. Yeah? Okay, so that now that you've seen that, does that help you? Okay. Let's see if you got this or started on that. Yeah. What do you mean? Well, I changed 9 pi over 4 into just pi over who? 4, which is just 1, right? So it'll be 1 minus the square root of 3 over 3 over 1 plus 1 times negative square root of 3 over 3, right? And when you put that in your calculator, you get square root of 3 plus 2, right? For homework, what I need for you to make sure that you do, I need for you to make sure that you do some sine, cosine, and tangent. I need to make sure that you take about 1 to 2 problems and evaluate, right? Yes? See you.